Good morning, everyone. How are you guys? All right, I appreciate that. I really do. Like, we need Saturday morning good vibes right now. Welcome, everyone, to our first talk. I am happy to introduce Alex Trudeau from Security Innovation.
Hey, everyone. Thanks for coming. This is the Pin Puller's Guide, a hands-on guide to reverse engineering iOS applications. I'm Alex Trudeau. Let's go ahead and get started. So who am I? I'm a senior security engineer with Security Innovation, basically a pen tester. My background's in electrical engineering, so that's how I started originally, and I was working with automotive facilities. I wound up finding some security vulnerabilities with that kind of stuff, and that sparked my interest. So for a year and a half, I was unemployed pursuing OSCP and CEH by myself, and that's how I got my foothold in the industry. I started off as a SOC engineer with an insurance company, and then Security Innovation picked me up about 4 years ago, so I've been with them ever since. I'm a CTF player. I do a lot of hack the box stuff. I also do the CactusCon CTF. That's a lot of fun. I learn a lot of stuff from them, and those guys are great. So if you have time to stop by the CactusCon CTF, I would highly recommend it. It's just an easy way to gain experience just doing different domains of security. I'm a mobile security enjoyer. My boss is Dinesh Shetty, who's the author of Insecure Bank version 2. So if you've ever kind of gotten into mobile security, you've probably come across that application at some point. So maybe he's had some level of impact on my interest in mobile. I've been a CactusCon attendee since 2022. This is the first time I've ever spoken. I'm very happy that I do it here because this is my favorite con. Woo! And let's go ahead and get started. So what is certificate pinning? So this is meant as a security mechanism where an application only trusts a specific certificate. If let's say I take my phone, I use the browser, and I navigate to something like example.com, https://example.com, it's going to present me a certificate, and that certificate's going to say, hey, I'm example.com. And I say, well, how do I know that? How do I trust you? And it says, well, hey, I have this certificate and it's signed by someone I trust. Like, let's say, I don't know, VeriSign, trust, whatever, some authority that says like, hey, this guy is who we say he is. So I say, okay, well, you're definitely example.com. I'm going to go ahead and connect to you. So then it works. Now, where certificate pinning plays in is if I'm going to that connection through an application that we'll take a look at later that says, hey, I'm example.com, does the certificate check and all that. Now, let's say I try to proxy my traffic. Certificate pinning plays a role in trying to prevent that from happening. So if I'm going through Burp, what Burp has to do is it has to re-sign the request with its own certificate authority. So I open up my application, I navigate to example.com through my application. Example.com says, hey, I'm example.com. I say, well, how do I know you're example.com? And because I'm proxying my traffic and say, hey, well, Portswigger vouches for me. Maybe my phone trusts Portswigger and says like, yeah, that's good. But the certificate pinning says, hold on, we don't know who Portswigger is. We're not going to accept the connection. And then it prevents me from establishing a connection with example.com. So it's just a way to prevent attackers from intercepting and modifying traffic. Implementation varies. You could have a pretty simple certificate pinning implementation that's like trivial to bypass, and we'll look at that later. But then you can have a little bit more complex implementations that might require a little bit more reversing. Google actually recommends against certificate pinning in their docs, which I have linked there. So the reason why they do this is because when a certificate expires, you are unable to like use the application. Pushing out a new update for an app costs money, time, and it's just a pain. This is a classic CIA triangle problem: confidentiality and integrity and accessibility. So it's like as security people, we might say like, hey, you definitely want to put cert pinning in there because it prevents attackers from messing around with the traffic. But as a developer, you're like, hey, I just need my app to work, man. And I don't want to do this. It's going to create a bunch of problems for my customers. So it's, it's constant balance. So the objectives for today is we're going to explore a manual technique of bypassing certificate pinning in an iOS app. We're going to use NSA's Ghidra to figure out where the certificate check's occurring and how to go about debugging issues that we'll inevitably run into. We're going to reference the source code and explain why we had to go through this process. But more importantly, I want to empower all the attendees to use this reversing methodology for their own research. So what we're looking at today is just certificate pinning bypass, but you could actually take a look at different logical issues within the application, use this same technique, and bypass different features. So the target for today, as I'm using the damn vulnerable iOS app powered by 8ksec.io, they're another great mobile security company. If you want to learn more about mobile stuff, definitely recommend checking them out. I have the GitHub linked here. It's all open source, and it's going to give us the .ipa file, which is basically the file that we use to install the application. It's great for learning iOS security. Definitely check out the DVIA if you're interested. So here's the attack plan. We have the .ipa file, which contains the application. It actually can be in zips, so we're going to unzip it and take a look inside. We're going to place the burp certificate inside of the application, because anytime as pen testers we see, oh, here's a certificate, I'm going to put my burp certificate in there, and then we're good to go. We're good to proxy traffic. But it's not going to work. You know, spoiler, doesn't work right away. But why is that? And we're going to load up the .ipa's binary file in Ghidra, which is like the file that contains all the logic. We're going to sort through the disassembled code to figure out where the check's actually happening. And we're going to make a little bit of use of Objection, which is a wrapper for Frida, to hook the identified functions to figure out where the issue is. And then we're going to fix the issue. We're going to pull the pin. So the tools that I'm going to be using today is, just for the sake of simplicity, I'm using a rootful jailbroken iPhone X on iOS 16. You can do this on jailbroken or non-jailbroken devices, but that goes outside of the scope of this talk. I'm going to be using Portswigger Burp Suite, everyone's favorite tool for proxying. Frida is going to be our tool for hooking functions, objections, the wrapper around that. And then we're going to be using the NSA's Ghidra as our primary reversing tool. So to pull the app, so I don't need to pull the app because it's on GitHub. Yeah, so yeah, you could just download it on GitHub. Yeah, if you wanted to pull, like, there's multiple methods of getting IPA files. Yeah, let's please save questions for the end. Thanks. That's a great question though. You can use like iOS dump or something like that for the IPA. Okay, so let's go ahead and just take a look at the app. So this is the DVIA application. This is just the home screen. It's got device info there. Just if we hit this hamburger menu here, there's a bunch of different challenges. So the one that we're going to be taking a look at today is this network layer security. So let's just go ahead and click here. We'll say, just got to fill in some information. Come say hi at the security innovation booth. And then what we're going to be focusing on is just these first three buttons. Public key pinning is something that I'd encourage you to take a look at on your own time. But we're just going to be looking at send over HTTP, send over HTTPS, which is secure HTTP, and then we're going to send using certificate pinning. So that's the main thing that we want to take a look at. And then this like app transport thing is just like an info box. So we're going to go ahead. I'm just hitting the HTTP button, says request sent, look out. HTTPS, request sent, look out. And now we're going to hit the certificate pinning one, and it says request sent using certificate pinning, look out. Now, this is a message we want to remember because I'm going to reference it later on, but just remember we get this like little success message, okay? So that is kind of an overview of the app. So the next thing that we want to do is I'm going to say, hey, well, I want to proxy the traffic. So I'm just going to go over here. I'm already inside of my iPhone. I think that it has the listener set up already. So I am going to pull up my burp over here. I'm just going to get rid of some of this. Oops. Get rid of some of this traffic. and I am going to pull the app back up. So what I'm going to do is I'm going to go into my proxy settings, and I'm just going to set this up to localhost on 8080. Localhost 8080. Okay, and now we should be proxying traffic. So I'm going to go back to my application, send over HTTP, and we see on the left side, there's a request that was sent to Burp. So you could see there's all my information I put in. Notice this is HTTP to example.com. I'm going to go ahead and send over HTTPS. And that sends to HTTPS with example.com. So bear in mind, I've done a little bit of groundwork and I already added my Burp certificate to my system trust. So that's why this button's working. But let's go ahead and see what's going on with the next button. It says certificate validation failed. You'll have to do better than this. So, well, what's going on? I put my Burp cert in, it should work. So clearly there's something going on. We need to figure it out. What exactly is happening? Now, I just want to kind of showcase a simple way that we could do the certificate pinning bypass. So I'm going to use Objection. So the first thing I'm going to do here is, let's go ahead and, I'm just going to use Frida, which is already running on the application. And I'm just identifying the package. So we're going to do Objection G for gadget, high altitude hacks.dvia, Swift v2. And then this little code at the end. All this code will be unique for everyone. This is just like kind of a developer code. Explore. I probably just mistyped it. Let me just go ahead and copy it. Oops, that's not what I wanted. Sorry, I'm trying to get used to this Mac trackpad. I'm used to doing this on Windows. Objection G explore. Okay, so we have Objection here. So this is like the tool that we're, oh, I might be hitting the desk. It's good now. So it reopens my application, and you could do something like this. So within Objection, there is iOS SSL pinning disable. So we're just going to run that. And what this does is it actually hooks into lower level functions in the phone. It might have just been because I locked the screen. Okay, iOS SSL pinning disable. Okay, so it's hooking into lower level methods, and this should be able to bypass the certificate pinning. So if I go back to Burp here and just keep an eye on that, I'm going to go to my network layer security screen. I'm just going to hit the certificate pinning. It looks like something's happening over here. There's hooking into lower level functions. And then with Burp, we see that we did indeed get a GET request, right? So this button just functions differently for whatever reason. I'm not sure what the motivation was behind that for the developers, but we have a GET request here. So it bypassed, but look, there's no message that popped up on my phone. It doesn't say that request is sent. So clearly I'm not stepping through the intended path of the application. So when you try to do this method, and like hook into the lower level functions, you're actually potentially missing out on critical code paths. Maybe there's something happening if I went down the proper one. So let's figure out exactly where this is happening. So let's go ahead and open up Ghidra. So what Ghidra is just this reversing tool. What you can do is just like you can import a file and just import the binary, or I could do the batch import. Already done this already. Inside of the DVIA IPA file, if we unzip it, it creates this like payload folder. Inside of the payload folder, there's the app folder, and then here's the binary here. Actually, let me back up a bit. If we go into our docs, this is just kind of like a demo of like, here's the IPA, unzip it, creates this payload folder. This is actually a folder, but just because of the nature of Mac, it's not displaying as such, but inside of here is like the certificate and stuff like that. So going back to Ghidra, let's go ahead, and we already have this open. So we have this code browser open, okay? So on the left side is basically just raw assembly. And then on the right side is the decompile screen. So this is Ghidra's way of like just trying to approximate what the code actually looks like. And we're approaching this as if we don't have access to the source code. So this is just like a pure reversing method. And there's a bunch of assembly, a bunch of code, and we don't know exactly where to look, but we could do something like search for program text. So I'm going to go ahead, click on search for program text, and we're going to search all fields. And remember, we had this error message. You will have to do better than this. Right? So I'm going to go ahead and just search for that. And while that's going, again, this kind of goes back to the classic CIA problem of confidentiality, integrity, and accessibility, because when I hit that button for the certificate pinning and it failed, it pops up with a little error message that says, certificate pinning failed. You'll have to do better than this. And that's really good from a user standpoint, because I'm like, oh, well, I know what's going on. I know why this error message is popping up. But from a security standpoint, it's like there's some maybe like motivation to be like, oh, well, what if I just returned an error that just said error? And it's like, well, that's good, because now attackers can't use that information to like, search inside of the code to figure out where this is happening. But like, you want to be able to tell your users what's actually going wrong, right? So you got to balance these things out. So as this looks like we have some results popping up. And again, you want to do search all. If you do like go to next and go to the next message where it says certificate pinning, you could like miss it. So I definitely recommend doing search all. And you'll see on the left side, we're kind of jumping to different points in the assembly code. So we have that. And on the right side is like the decompiled code. So we have arrived at maybe the general place of where this is happening, right? So we see DVIA version 2 transport layer protection. Well, that's not network layer, but maybe that's the same thing. I'm approaching this as if I've never looked at the code before. So this sounds like maybe it could be right. There's a NS URL connection. That sounds pretty relevant. So we scroll down here and we're seeing, what else is in this code. Well, we see example DER. Well, that's definitely pretty familiar, because that was the name of the certificate that was in the application. I don't think I showed that, but it is the name of the certificate within the application. So, okay, we're loading a file. That seems good, right? Now, scroll down a little bit more. We see, there it is. There's our message. Certificate validation failed. You'll have to do better than this, right? Okay, so this code is happening within an if block. This is fairly simple, like programming concept, just an if block. If this is true, then it goes down this code path. Else, it goes down this code path. So the else, it looks like it hits certificate pinning sent, or request sent using certificate pinning. Look out. So that's the message that we do want to see, right? So in this if block, if b var3 is equal to false, it goes down this code path where we fail. If it's not equal to false, it goes down this path. So you'll notice on the left side, as when I'm clicking around, it actually on the left side, the assembly code that's relevant to whatever I just clicked on pulls up. So we see this instruction here, this TBNZ, which is like test bit and branch if not 0. This is the exact assembly instruction that's happening when this BV var3 equals false comparison is happening. So what we could do is we could actually, and I'm just going to kind of demo this. but we're not going to use this as a solution. But we could actually just select that patch instruction. And what we can do is change this from a TBNZ to a TBZ, which is test bit and branch if 0. And what that would do would change the logic of the application from bvar3 is equal to false to, bvar3 is not equal to false. So then if the certificates mismatch, then it'll just send the request anyway. And we get the pop-up that says like, hey, request sent using certificate pinning, even though my certificates don't match. So that could be a solution for us, but I don't want to go down this solution, and the reason why is because I don't even want to touch the logic of the application. I just want the code to remain the same, and the only thing that I want to change is just the certificate, right? So, well, what's happening? How is that bvvar3 getting set? So when I click here, I have my Ghidra configured where it highlights all instances of the variable. So we look on the right side of the screen, we see bvar3 is equal to true. There's a false, and then there's like some comparison here or something like that. So it says NSObject equals infix, and then it has like, it's comparing these like two variables. This seems like a pretty relevant line. Let's see like what is NSObject, right? So we can just go ahead and copy this line, and we could just straight up Google it. So I'm just going to look up NSObjects, and then there it is. So I have some Apple developer documentation there. That seems pretty interesting. I also can like use an LLM just to help me figure stuff out. So I'm just using like the hacktricks.ai. It's pretty helpful. The reason I'm using it is just because like I don't have to authenticate or anything like that. But I could just be like, can you explain this piece of disassembled code? And then I just paste that line. And just like a reminder, don't post your customers' like sensitive data into LLMs. But because this is open source, we're good, right? So I could just, and while that's thinking, we'll just go back over to NSObject. And then, so this is the root class of most Objective-C class hierarchies, yada, yada. So it's just, there's a bunch of different methods within here. Well, which one would be the relevant one that we want to look at? So why don't we just search for, like equal, something like that. And then we have an isEqual function. That seems pretty relevant. Maybe that's the right one because we're comparing two different values from Ghidra, right? And let's see what Hacktricks has to say. So I won't sit here and read the entire thing, but it's basically kind of giving us a rundown of what we were just talking about. Like, bvar3 is the variable that's being assigned, blah, blah, blah. It has like the line of code. And then let's see, does this even mention isEqual? Beautiful. So it actually also references this isEqual method. So, okay, that seems to be a pretty promising place for us to be able to hook into. So I'm going to go back over to my objection. I'm going to go ahead and unlock my phone. So I'm just going to exit, relaunch it. And then what we can do is actually on the, hopefully this doesn't fall. I know I got it. What we can do is like iOS hooking and then list class methods for NSObject, just to kind of show you. So there's 549 methods within NSObject. So that seems to be quite a bit. And then we could see there's like the isEqual one. Yeah, I passed it, but it's in there. So what we're going to do is iOS hooking, watch method. We're not going to do NSData yet. NSObject is equal. So I'm actually not going to pass any flags to this. And then before that, I'm not doing anything super interesting on the phone. I'm just navigating back to the network layer security challenge. And I'm going to go ahead and hit enter. And then I'm just on the phone. I'm hitting the send using certificate pinning button and see a bunch of stuff pops up, right? So there's a bunch of calls being made to this NSObject is equal. So if I go back to and just like kind of scroll up, there's a ton of stuff happening, and it's not immediately obvious like where the relevant check is happening. So maybe this isn't the best place to hook. And this is just something that you'll run into, that like, you know, you hook into the wrong function, you see a bunch of noise. And actually, so I'll also show you, so I'm just going to kill this job, jobs kill 823, oops, 823, 361. So that just stops the previous job from happening. And I'm actually going to add all the flags, right? And then this time, I will display the screen. So I'll do that, and then let's get the screen going. I'm just going to hit the send using certificate pinning button. My app crashed because there's so many calls and you're trying to hook everything. It just completely crashes the app. So maybe that's not the right place to go. So let's actually go back to Ghidra and figure out like, hey, well, are there any clues as to what else I could hook into? Well, I see this like NSData thing. There's some data manipulation happening with that. Perhaps there's something to do with NSData. So if we go back, you know, we could just ask Hacktrix like, hey, is there a method within NSData that's related to NSObject? Yeah, that's a decent enough question. So we'll do that, and then we could Google NSData. Same thing. All right, developer docs. That seems pretty interesting. So let's go ahead here. Same thing. We're just gonna search for equal. There it is. It has a isEqual function too. NSData is not the root level object within the iOS infrastructure. So this is going to be much smaller. And this might be something that's relevant to hook into. So let's see what Hacktrix has to say. And it basically just confirms, it's like, yes, there's methods within NSData that are related to NSObjects. And then it just talks about like how we might be able to like override the isEqual method within NSObject with NSData. That seems pretty promising. So let's go back over here. Just going to exit and relaunch my application. And what I'm going to do is navigate on the phone. I'm not showing, I'm just navigating back to the challenge. Network layer security. Okay. We're back on the challenge. And then all I'm going to do is iOS hooking watch method. And then we're going to do NSData is equal. And I'm actually going to pass all the flags. So on the phone, all I'm doing is hitting the send using certificate pinning button, and then we get some data, and nothing's like, you know, it's not whipping by or anything like that. And we kind of go up a page. Okay, that seems to be a substantially more digestible amount of data, right? We see at the bottom, the return value 0. That means the check is failing, right? So we want to make sure that that turns into 1 at some point. And we could even go up a little bit more. And then we see on this line where my blinking cursor is, well, that looks pretty familiar. The NSObject equals infix. Well, that's what we saw in Ghidra. And this is like, the call stack of like how this functions or this method is actually getting called. So, okay, this comes from NSObject, that comparison with bvar3. This is very, very likely what the check, where exactly the check is happening. Well, let's take a look at that argument dump. So we do have this NS concrete data is equal, and then it has a length, and then it has bytes. So that's probably our certificate that's being compared. Just as a nature of like objection, it doesn't actually show me the full output of all the bytes associated with a particular certificate that it's looking at. But that length seems pretty interesting. So what I probably should have displayed earlier is on my iPhone. So I'm just SSH'd into my iPhone right now, and I have some files on here. I have a burp.der. I have the example.der.backup, and then I have my PowerPoint slides, and then I have test.der as well, which we'll take a look at later. The relevant ones here are burp.der, which is my burp certificate, and the backup. So let's just run ls-al, which shows me, I'm going to go ahead and maximize the screen. It shows me just like the lengths and stuff. So the burp.der, hold on a second, that's 939. That doesn't match 919. So, well, where is that coming from? Where's that 919 coming from? The test.der is 919, but the burp one is not. So if I try to shove my burp inside of the application and it does that comparison, it's comparing 939 against 919. So of course it's going to fail. But again, where is that coming from? So I'm actually just going to open. So this is just Burp's browser. And remember, if I'm trying to proxy my traffic, Burp reassigns the certificate authority. It says, hey, Port Swigger says example.com. He's okay. You're good. Right. So let's actually click over here in the top left, go to certificate details. I know it's a bit small to read. Apologies for that. We have the certificate hierarchy being displayed here. So Port Swigger CA is at the top, and then example.com is below that. So maybe there's some kind of thing happening where instead of comparing the Port Swigger CA to the file that I've supplied to the application, it's actually comparing the top level or the example.com certificate. So there's going to be a mismatch there. And I can actually just show that by, let's just make a new screen, by using OpenSSL. So what I'm going to do is I'm just going to do OpenSSL, sclient, connect, example.com on port 443. We're going to, was a proxy at localhost 8080, and then we're gonna show certs. So hopefully that connects, and it does. And then we see so this is all I did was I made a request through Burp to example.com, and we could see the certificates that are returned inside of that connection. So we have at the top, with 0 there, and keep that 0 in mind, there's example.com. This is the certificate for example.com. If I go down a little bit, and we see the second certificate with the index 1, that's the Port Swigger CA certificate. Okay, so now what we're going to do is we're going to take a look at this certificate, and we're just going to copy it. So hopefully my trackpad wants to be nice to me. Apparently it does not. Oh my God. I don't know how people use trackpads. Yeah, I don't know how to use a computer, honestly. As I'm sure you all can tell. So I'm just going to go ahead and just remove this test.der file. Let's actually remove the test.pem file as well. So yes, you'll see the abomination of me using Nano. So I'm just going to go ahead and copy this certificate in. A what? There might be. Oh, was there oh, that's what I did. Yeah. Okay. Oopsie. OpenSSL, we're just going to convert this from PEM format to DER format. So in test.pem, out test.der, out, was it out form DR? Okay. Did I not save it? Uh, 509 and test.pem. Does it not find certificate?
Try copying again.
Is it just like not formatted properly? It's at the top. Oops. That is not what I wanted. Yeah, this looks to be the right format. So I'm not quite sure why this is happening, but I think we might need to go nuclear and use my backups. Open in case of catastrophe. That's what's happening right now. So basically what should have happened is that I convert the PEM file to a DER file. All I do is I SCP, or secure copy, over to my iPhone, and all we do is we just write that file to the certificate inside of the application. So I'm going to go ahead and just show the screen recording. So this should be once I have the successful, certificate inside of the application. So that's me. This is a consequence of, hold on, I'm just gonna pause it. This is a consequence of me having a jailbroken iPhone. I have like sudo on it and stuff. Like this won't work on a non-jailbroken phone or a jailbroken phone that's rootless. But I'm able to just like, cat the file into the example certificate, and then you can see there's my burp traffic. I'm just going to go ahead and clear it. Then we're just going to hit the send over HTTP. Look out. Send over HTTPS. And now we're going to hit that final button. Request sent using certificate pinning. And it's supposed to show up, but I think that I was like running into some kind of issue with my tunneling, and there it is. There's the GET request. And not only is there the GET request, but I got the request sent using certificate pinning. Look out, right? So now we've successfully bypassed certificate pinning while also maintaining that code path that we went down inside of Ghidra. So with that, that pretty much wraps everything up. Let's see how we're doing on time. Got a lot of time. So yeah, with that, we could just kind of hop into Q&A here.
Do you want to show like the index check?
We can show the index check. Oh yeah, the source code. That's right. So we can actually go into the source code and figure out where this is happening. So I've actually already kind of navigated to the relevant spot within the source code, and we could see, certificate validation failed. You'll have to do better than this. We can see the request sent using certificate pinning. Look out. And then if we kind of go up here, we could see, let certificate equal this SecTrustGetCertificateAtIndex. And remember I pointed out that 0 earlier that was pointing to example.com. Well, that's what's happening here is we're passing a (0), right? Which means get the top level for the comparison. And, again, if we want just to showcase AI, just like go into Safari and just be like, can you explain what this Swift code does? And then that'll kind of give us like basically what I was saying about there it is, 0 is the index of the certificate in the chain. So that's why this whole problem was happening. So because of like the implementation of certificate pinning, it was only checking the root level certificate. It was only checking the server level certificate. So I was passing in my burp certificate, but that's the root level, but it was looking for the server, and that's where the whole disconnect was happening, right? And again, it's like if you run through Objection with just the iOS SSL pinning disable, that's going to hook into lower level functions, and maybe you'll be able to bypass the pinning, but you're not going to get the same code path. Right. So if let's say that there was like some secret bit that was set in that code path, right? I'm just using SSL pinning disable. I'm hooking it to boring SSL or whatever native library. It does the bypass. Well, it's not going to go down that code path, and that bit's not going to get set. Right. So that's why definitely want to take a look at the method that I'm showcasing here with reversing. You know, maybe you're a little bit better at the trackpad or being able to convert files, you know, but that should kind of, showcase the whole technique. We looked at the source code. We demoed the pinning bypass and all that. So with that, I think we're good to go into Q&A. Any questions from anyone? And also, please speak up. I have trouble hearing. Yes. What iPhone emulator am I using? I'm not using an iPhone emulator. I have a physical jailbroken device. Yeah, I was just using QuickTime to just show the screen there. Again, you can do this on a non-jailbroken device, but it's going to be a little bit of a different like setup harness, stuff like that. But just for the sake of simplicity, I used a jailbroken iPhone. Check out Corellium if you want a emulator though for iOS. Any other questions, comments? There's still a lot of work to defeat. Yeah, it was a lot of work to defeat the pinning. Is this technique still useful? Yes. Yes, it's a lot of work to manually go through, but this kind of provides us with a true understanding of the underlying infrastructure of the application and what's happening. So yeah, it's time consuming. You could take the easy way out of doing the iOS SSL pinning disable, but exactly as I showcased, there's a very likely scenario where taking a shortcut could lead you down the path of not taking the correct path in the application. Yeah, it just may not work. Just straight up, you know. Question?
This technique that you're saying can sometimes hamper error messages. It's something that you why does Google on some of the update cadence recommend against it?
Why does Google recommend against certificate pinning against the cadence? I mean, like it's a measure that's almost always going to be defeated, just kind of as I showcased. And it's a balance of like, well, you know, attackers are going to hit us anyway. Maybe we should focus our security like in other places. Like even if I'm able to intercept traffic, if devs focus on like, hey, we're not going to let, you know, server traffic delete other people's data or something crazy like that. That's where most of our security efforts should go into, and not just making it harder for people to intercept traffic. So the security should be like from on the server side. Doesn't need to be super focused. Does that answer your question? Okay, cool. Any other questions, comments? Question?
Do you have plans on improving your trackpad usage in the future?
I have zero plans of improving my trackpad in the future. I have zero issues with the embarrassment that I faced. And yeah, you know, it is what it is. So yeah, thanks everyone so much for your time. I really appreciate it. Again, this is my first talk, was definitely nervous, as I'm sure you could tell. If you'd like to add me on LinkedIn, I swear that QR code is safe. You know, more than welcome to scan it. I'll be at the Security Innovation booth. Drop by and say hi. I don't bite. Just super happy to talk to people. And again, thanks again. I really, really appreciate it. I'm very, very happy to be here. And thanks.